Hey Mike, I'm figuring this one out. This is a nasty one. So the equation according to this here, C is equal to 1.18, open brackets E taller drama. It follows the same form as this equation on page 247 in the Indian text. This is in chapter 10. So if we just compare KET, the KE would be 0.24, that's from up here, and the KAT, KA is 1.6, as you can see there, 1.6 T. Also, this big KAFEX Euler drama, that is equal to 1.18. So we kind of have an idea of where those things fit in. Now for part A, the peak time, which is the Tmax, it's the same equation on page 247 as the same below here. 2.3 or 3 log Ka over Ke all divided by Ka minus Ke. When you plug in the values, so when you plug the values in, this is what you get. And that is all equal to 1.4 hours. 1.4 hours. So that's the first part. Alright, so the second part, part B, peak plasma concentration. Well, now we know the Tmax is 1.4. So you just plug that value into the same equation. So when we plug all the values in, Cmax is equal to the same equation, just with the 1.4 in showing up here. When you do all of that, the answer for that works out to 0.7176. So that is how they got micrograms per hour. Alright, so far so good. Part C, the elimination half-life of the drug. Well, we know the T half is equal to 0.693 all divided by Ke, elimination rate constant. And when we work it out, that works out to 2.888 hours. So far, not too bad, eh? Now part D, for this, remember we talked about this whole long, ugly looking thing here. That entire thing is equal to 1.18. So let's just plug in values and see what happens. Okay, so notice that we suddenly have a VD here. From page 247, the original equation started off as X is equal to all of that, but then they switched across to concentration. So to go from X to C, you have to divide by VD right across. So the concentration is equal to KFX0 over VD into Ka minus Ke into the e to the Ket minus e to the Kat. So if you look at the equation, that's 10.49 on page 247. We're using that equation, and we just plug in values. Okay, and then when we simplify all of this and we solve for VD, we will end up with VD is equal to 199.4 200 liters. Right, so that is part D. And the last part of this question is easy. The concentration after 3 hours, just use T here, 3 hours. And when you solve all of this, you end up with 0.565 micrograms per mil. So, there you have it, parts 1, 2, 3, 4, and 5. 1, 2, 3, 4, 5. Yeah.